August 17, 1943. The Mediterranean sun beat down on the rocky slopes near Messina, Sicily, as Oberleutnant Werner Hoffmann knelt beside the body of an American infantryman. The soldier had fallen during the chaotic American advance across the island, his backpack still strapped to his shoulders. Hoffmann's orders were clear. Capture any American radio equipment intact. Berlin wanted to know what the Allies were using. As Hoffmann carefully removed the 35-pound pack, something felt wrong. German infantry radios required 2 men to operate, one carrying the transmitter and receiver, another lugging the separate battery pack, connected by cable. Yet this American soldier had been operating alone, moving freely with his company. Inside the olive-drab case, Hoffmann discovered an 18-tube FM transceiver, complete with batteries, control unit, and 2 antenna sections, all integrated into a single backpack system that one man could carry and operate independently. The frequency dial showed channels from 40 to 48 megacycles. VHF band, the same range where German tank radios operated, but this was infantry equipment, designed for common soldiers. 2 days later, that captured radio sat on a workbench in a requisitioned villa outside Catania, where German signals intelligence maintained a forward technical evaluation unit. Hauptmann Klaus Dieter, a communications engineer who had designed components for the Wehrmacht's Torn-Fu radio series, began his examination. He had spent 5 years helping develop Germany's infantry radios, equipment he knew intimately. What he discovered in the next 72 hours would challenge everything German engineers believed about battlefield communications and what was possible with mass-produced military equipment. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story of how German engineers reacted to captured American radio equipment reveals not just a technological gap, but a fundamental difference in industrial philosophy. It's a story about frequency modulation versus amplitude modulation, about design for manufacturing versus craftsman assembly, about the collision between German technical excellence and American industrial capacity. Most importantly, it's a story about the moment German engineers began to understand that the war would not be won through superior engineering alone. To understand the shock Klaus Dieter experienced that August morning in Sicily, we must first understand the state of battlefield communications in 1943 and the fundamental differences between how Germany and America approached the problem of mobile infantry radio. Since the beginning of the war, the Wehrmacht had relied on the Torn-Fu series of backpack radios. Torn, short for tornister or knapsack, designated portable infantry equipment. The most common model, the Torn-Fu D2, operated in the VHF band from 33.8 to 38 megacycles. It transmitted 1.5 watts of power using amplitude modulation for voice and continuous wave for Morse code. Under ideal conditions with an elevated antenna, it could achieve 10 to 12 kilometers range using Morse code, or 4 to 5 kilometers using voice. But the Torn-Fu D2 required 2 soldiers to operate. One man carried the transmitter-receiver unit weighing approximately 15 kilograms. The second man carried the battery pack, weighing another 12 kilograms, along with the handset, Morse key, and accessories. A cable connected the 2 soldiers together. They could move, but not independently. This design reflected fundamental constraints in German radio engineering: the need for separate high-voltage batteries to power vacuum tubes, the bulk of AM circuit components, and the weight of lead-acid batteries that could sustain field operations. Every German infantry battalion had 4 Torn-Fu D2 radios to maintain communications between companies and battalion headquarters. The equipment worked reliably when properly maintained, but it had limitations that frustrated infantry commanders. The 2-man requirement reduced tactical flexibility. The AM modulation picked up interference from vehicle engines, electrical equipment, and atmospheric conditions. The limited range meant infantry companies advancing beyond 4 to 5 kilometers lost contact with battalion headquarters unless they stopped to extend relay antennas. German engineers understood these limitations. They had experimented with frequency modulation, which offered superior noise rejection and clearer voice transmission. But FM required significantly more complex circuits, precise frequency control, and specialized components that were difficult to manufacture in quantity. German industry in 1943 was focused on producing existing weapons in maximum quantities, not developing sophisticated new technologies for mass production. The decision had been made. Stick with AM for infantry radios, reserve FM for specialized applications where the added complexity could be justified. American radio development had followed a different path, driven by one engineer's determination to give infantry troops something better. In September 1940, Daniel Earl Noble walked into the Galvin Manufacturing Corporation in Chicago as the company's new director of research. Noble brought specific expertise that would prove crucial. He had designed and installed the nation's first statewide two-way FM radio communications system for the Connecticut State Police, completed earlier that same year. He understood what FM could do: static-free communication, resistance to electrical interference, and clarity that AM systems simply could not match. Noble arrived at Galvin Manufacturing at a moment when the U.S. military desperately needed better battlefield radios. The Army's existing portable infantry radios, the SCR-194 and 195, were notorious failures. They used primitive super-regenerative circuits operating on AM frequencies. Every vehicle engine, every electrical motor, every thunderstorm generated static that drowned out vital communications. The radios were so unreliable that many infantry officers preferred sending runners carrying messages by hand, even though runners could be killed or captured, even though messages might arrive too late. Galvin Manufacturing had achieved some success with the SCR-536, a handheld AM radio nicknamed the Handy Talkie. It was compact, crystal-controlled for frequency stability, and truly handheld, but its maximum effective range was approximately 1 mile under good conditions, useless for communications between companies and battalion headquarters several miles to the rear, useless for forward observers directing artillery fire from observation posts miles from the gun batteries. In early 1941, the Army Signal Corps contracted for development of a new portable infantry radio. The specifications called for AM technology, the safe, proven, conservative choice. When Noble learned of this decision, his response was immediate and risky. He told Army officers directly that developing an AM portable radio was a grave mistake. He argued forcefully that FM was the right technology for portable military radio, despite the Army's clear preference for familiar AM systems. Noble was asking busy military procurement officers to trust his technical judgment over their own institutional preferences. He was advocating for a more complex and potentially more expensive solution when the simpler option seemed adequate. He was staking his professional reputation on beliefs that many considered theoretical rather than practical, but Noble understood something that others had not fully grasped. Soldiers operating in the electromagnetically hostile environment of modern mechanized warfare needed communications that would work reliably despite massive electrical interference. They needed clear voice transmission at the limits of range, where the difference between understanding and confusion could mean the difference between coordinated action and catastrophic failure. The Army Signal Corps agreed to gamble on FM technology. In 1942, Galvin Manufacturing received a contract to develop a portable FM infantry radio, designated SCR-300. The specifications were demanding. The complete radio system could weigh no more than 35 pounds, had to be carried on one soldier's back, must operate in all weather conditions with waterproof construction, needed to provide reliable communications over at least 3 miles, and had to cover the 40 to 48 megacycle VHF band using frequency modulation with minimal crystals. Noble assembled an engineering team: Henrik Magnuski as principal RF engineer, Marion Bond, Lloyd Morris, and Bill Vogel. He gave them one message: the Signal Corps has placed a life and death priority on this program for the infantry. Soldiers' lives would depend on whether this radio worked reliably in combat. The engineering challenge was formidable. Frequency modulation required complex circuits that were difficult to stabilize. Vacuum tubes needed high-voltage power supplies. Batteries capable of sustained field operation added significant weight. Everything had to be ruggedized for combat conditions while remaining light enough for one soldier to carry. The entire system had to be simple enough for infantrymen with minimal technical training to operate reliably under fire. By spring 1942, the team had 2 working prototypes. For final testing, they chose an ambitious demonstration. Daniel Noble and a colleague stood 8 miles apart in the fields of Fort Knox, Kentucky. When Noble pressed the transmit button and spoke into the handset, his colleague 8 miles away heard every word with crystal clarity, free of static and interference. The Army had specified a minimum range of 3 miles. The prototype had just demonstrated more than double that distance. The Signal Corps officers present at Fort Knox that day were impressed enough to approve full-scale production. What they were witnessing was a radio that would give American infantry a decisive communications advantage. What they couldn't yet know was how that advantage would appear to German engineers examining the equipment after capturing it in combat. The SCR-300 that emerged from Motorola's production lines represented a leap forward in battlefield communications technology. The radio itself, designated BC-1000, was an 18-tube FM transceiver using a double superheterodyne receiver design. It incorporated automatic frequency control circuits that maintained stable operation without constant manual adjustment. German radios required operators to continuously adjust tuning to compensate for temperature drift and component aging. The American radio tuned itself. The frequency selector allowed operators to choose any of 41 channels across the 40 to 48 megacycle VHF band. A squelch circuit eliminated background noise when no transmission was received. The frequency calibration used a crystal-controlled oscillator with harmonics marked on the channel display, allowing precise tuning without external equipment. 2 antenna options were provided: a short 33-inch whip with an LC matching circuit for close-range communication, and a 10-foot 8-inch half-wavelength antenna in 9 collapsible sections for maximum range. The transmitter produced a minimum of 300 milliwatts of carrier power. The receiver sensitivity was guaranteed at 4.5 microvolts minimum. These specifications promised reliable 3 to 5 mile range in varying terrain. The entire system with batteries weighed 35 pounds, exactly meeting the original specification, light enough for one soldier to carry and operate independently while moving with his unit. Production began in earnest during 1942. By the time Sicily was invaded in July 1943, nearly 50,000 SCR-300 units would be manufactured. The first units were transported by air for use in the invasion of Italy. Such was the priority placed on getting these radios to frontline troops. Now, we return to that requisitioned villa outside Catania in August 1943, where Hauptmann Klaus Dieter began his systematic examination of the captured American equipment. Dieter started with external inspection. The radio was housed in a sturdy steel case painted olive drab. Heavy rubber gaskets protected every seam and connector. The construction quality immediately struck him as exceptional. German military radios were well made, but this level of protection against water, dust, shock, and temperature extremes exceeded anything in Wehrmacht infantry. The case was designed for soldiers who would carry this equipment through rain, mud, river crossings, and jungle humidity without any expectation of gentle treatment. When Dieter opened the case and examined the internal construction, his first reaction was confusion, followed by growing unease. Everything inside was standardized, modular, designed for mass production. Every component was identical to specifications documented in the accompanying technical manual that had been captured with the radio. There were no hand adjustments, no technician marks indicating individual tuning during assembly, no variations that would require skilled labor. This was equipment designed to be built by semi-skilled workers in factories that could be replicated across an entire continent. German radio production required trained technicians to hand-tune circuits during assembly. Each radio was slightly different, requiring documentation of its specific adjustments. The American radio needed none of that. Any SCR-300 could be repaired using parts from any other SCR-300. Standardization and interchangeability at a level German industry had never achieved in military electronics. Dieter then examined the frequency control system. He expected to find simple, perhaps salvaged civilian components. Instead, he discovered precision quartz crystal oscillators, hermetically sealed in metal holders, each ground to tolerances measured in parts per million. The automatic frequency control circuit used these crystals to maintain rock-solid frequency stability across temperature variations and power supply fluctuations that would render German radios useless. But what truly shocked Dieter was discovering that this was standard equipment for ordinary infantry soldiers. This wasn't a radio for regimental commanders or special operations units where sophisticated equipment might be justified. This was the radio issued to infantry battalion signal sections, carried by private soldiers, operated by men who might have been farmers or factory workers 6 months earlier. The implications became clearer as Dieter conducted transmission tests over the following days. He set up the captured SCR-300 with its full 10-foot antenna and powered it from a German field generator. His assistant took a German Torn-Fude 2 radio 5 kilometers away to the east, near the coastal town of Sicily. They would test both radios simultaneously under identical conditions to compare performance. At 1500 hours on August 19th, Dieter transmitted on the American radio. His assistant, 5 kilometers distant, reported receiving the transmission with perfect clarity. No static, no interference from nearby German vehicles, no atmospheric noise. The FM signal cut through everything. Then they reversed the test. The German Torn-Fude 2 transmitted from Sicily. Dieter, listening on the German receiver, heard the message, but it was degraded by engine noise from Wehrmacht trucks passing nearby, overlaid with the characteristic hiss and pop of AM static. They increased the distance to 7 kilometers. The American radio still maintained clear communications. The German radio's voice transmission became marginal, difficult to understand without repeated transmissions. At 10 kilometers, the SCR-300 was still usable for voice, though beginning to fade. The Torn-Fude 2 at that range required switching to Morse code for reliable communication, and even then, the signal was weak. Dieter wrote in his initial assessment report that the American infantry radio represented a capability that exceeded German regimental-level equipment in both range and reliability, yet it was apparently issued down to battalion level, possibly even to company level based on the circumstances of its capture. The FM modulation provided interference immunity that made it practical in the electrically noisy environment of modern mechanized combat. Most concerning, the design and construction suggested mass production at a scale Germany could not match. That evening, Dieter discussed his findings with Oberst Friedrich Müller, commander of the Signals Intelligence Detachment. Müller had been a professor of electrical engineering before the war and understood the implications immediately. If American infantry companies could communicate reliably over 5 miles, while German companies struggled beyond 3 or 4 kilometers, American forces would maintain superior command and control. They could coordinate faster, adjust to changing situations more quickly, bring artillery and air support to bear with greater speed and accuracy. But the real concern was what this radio revealed about American industrial capacity. Müller pointed out that the technical manual captured with the radio indicated it was designated Radio Set SCR-300-A, suggesting there had been earlier versions, refinements, continuous improvement. The manual was professionally printed, comprehensive, designed for soldiers with minimal technical knowledge. Everything about this equipment suggested a mature production system, not an experimental prototype. If the Americans were equipping infantry battalions with radios this sophisticated, Müller asked, what were they giving to armored units, to artillery, to air forces? And more important, how many were they producing? Dieter had no answer to that question, but his examination of the radio's components provided disturbing clues. The vacuum tubes were standard types, manufactured to tight specifications, interchangeable, not specially made tubes that would require dedicated production facilities. The capacitors, resistors, and other components were military-grade, but using manufacturing techniques that suggested high-volume production. The crystal oscillators were the most telling. These were precision components that in Germany required laboratory work, skilled technicians, time-consuming grinding and testing. Here they appeared as standardized units, marked with specifications, sealed for reliability, installed as casually as light bulbs. Germany in 1943 was experiencing severe shortages of many materials critical for radio production. Quartz crystal for frequency control was particularly scarce. German radio designs minimized crystal use, often relying on less stable but more available variable capacitor tuning. The Americans apparently had enough precision quartz crystals to install automatic frequency control systems in infantry radios, equipment that might be lost or destroyed in any firefight. Over the next week, as Allied forces completed their conquest of Sicily, more captured American radio equipment reached German technical intelligence units. Additional SCR-300 radios were recovered, some damaged, some intact. Each one confirmed what Dieter had discovered. This was standardized equipment, mass-produced, built to identical specifications. Serial numbers on different units showed they had been manufactured months apart, yet the components were completely interchangeable. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. German signals intelligence also intercepted American radio traffic using the SCR-300 during operations in Sicily. What they heard was revealing. American infantry units communicated freely, frequently, coordinating movements with a casualness that suggested they had complete confidence in their communications. German doctrine emphasized radio silence to avoid direction finding, transmitting only when necessary because radio communications were assumed to be vulnerable and unreliable. American forces seemed to operate under different assumptions. Their radios were so reliable, so resistant to interference, that they used them constantly. This difference in radio doctrine reflected deeper differences in military organization. German infantry tactics emphasized written orders, runners, and physical coordination because radio communications were limited. American tactics increasingly relied on radio as the primary means of command and control because their equipment made it practical. Superior communications allowed American forces to coordinate combined arms operations more effectively, adjust to changing situations faster, and maintain the initiative even when German forces might have tactical advantages in other areas. The captured SCR-300 was eventually transported to Germany for more detailed technical analysis. It arrived at the Army High Command's Signals Research Facility outside Berlin in September 1943. Dr. Heinrich Weber, director of the Radio Development Section, supervised the comprehensive evaluation. Weber had spent his career in radio engineering. He held patents for several innovations in AM receiver design and had consulted on the development of Germany's Fugue series of tank radios. He approached the American equipment with the skeptical confidence of someone who had seen many foreign radios and understood German equipment to be among the world's finest. His team disassembled the SCR-300 completely. Every component was catalogued, measured, tested. They traced circuit designs, analyzed the frequency modulation system, examined the automatic frequency control mechanism. They tested the radio's performance under various conditions, simulated field operations, measured sensitivity and selectivity, evaluated the transmitter's spectral purity. The technical evaluation took 3 weeks. Weber's final report to Wehrmacht High Command ran to 47 pages, including detailed circuit diagrams, performance measurements, and strategic assessments. The conclusions were stark and troubling. The report confirmed that the American infantry radio used frequency modulation technology superior to German AM systems for battlefield applications. The FM system provided approximately 10 to 15 decibels better signal-to-noise ratio in the presence of electrical interference compared to German AM equipment. This meant American radios could maintain communications in environments where German radios would be unusable. The automatic frequency control system using precision crystal oscillators eliminated the need for constant manual tuning and provided frequency stability that German radios could not match without dedicated operator attention. The construction quality and ruggedization exceeded German military standards. The radio was designed to function after being dropped, submerged in water, exposed to temperature extremes from -30 to +60 degrees Celsius, operated continuously for extended periods without maintenance beyond battery replacement. German radios required more frequent maintenance and were more susceptible to failure under harsh field conditions. But Weber's most significant finding was about manufacturability. Every aspect of the SCR-300's design reflected an obsession with mass production. Components were standardized for interchangeability. Assembly required no specialized skills beyond careful attention to instructions. Testing and calibration were built into the design through self-adjusting circuits and calibration crystals. Quality control could be achieved through go-no-go testing rather than skilled technician evaluation. Weber calculated that a factory with semi-skilled workers could produce SCR-300 radios at perhaps 5 to 10 times the rate that German factories produced Torn-Fu radios, even accounting for the greater complexity of the FM design. The American emphasis on design for manufacturing meant that their more sophisticated radio could actually be produced faster and cheaper than Germany's simpler equipment once the production system was established. The strategic implications section of Weber's report made for grim reading at Wehrmacht High Command. If the Americans could produce sophisticated FM infantry radios in quantity, they possessed industrial capacity and technical capability that exceeded German estimates. The radio represented not just superior equipment, but a superior industrial philosophy. Design for mass production. Build quality into the process. Create systems that don't require skilled operators or maintenance technicians. This approach allowed America to field advanced equipment in quantities that German craftsman-based production methods could never match. A technologically superior German radio that could only be produced in limited numbers would be overwhelmed by slightly less sophisticated American radios produced in unlimited quantities. The side that could build more equipment, faster, with less skilled labor, would ultimately prevail regardless of theoretical technical superiority. Weber noted in his report that Germany faced a fundamental choice: attempt to copy American production methods, which would require complete reorganization of manufacturing systems and might not be achievable with available resources and industrial infrastructure, or accept that Germany could not match American production quantities and develop tactics and strategies that worked around this limitation. The reality, though Weber did not state it explicitly in his official report, was that neither option was viable in 1943. German industry was fully committed to producing existing weapons. The resources and time required to reorganize for American-style mass production didn't exist, and no tactical brilliance could overcome a 3-to-1 or 5-to-1 numerical disadvantage in critical equipment sustained across months and years of combat. Wehrmacht High Command filed Weber's report with other assessments of captured Allied equipment. The information was classified, distributed only to senior officers and technical specialists. Some commanders took the warnings seriously and adjusted their tactical planning accordingly. Others dismissed the concerns, arguing that German technical expertise and superior training would overcome any Allied material advantages. But in the field, German soldiers increasingly encountered American units with communications capabilities that exceeded their own. American infantry companies maintained constant contact with battalion headquarters. American artillery forward observers called fire missions with speed and precision that German observers could not match. American armored units coordinated with infantry support more effectively than German combined arms doctrine anticipated. The communications advantage provided by the SCR-300 and similar FM radio equipment was not by itself decisive in any single battle, but sustained across thousands of engagements from Italy to France to Germany, it contributed materially to Allied victory. Superior communications meant better coordination, faster response to changing situations, more effective use of firepower, and reduced vulnerability to surprise or encirclement. By 1944, as Allied forces invaded Normandy and advanced across France, the SCR-300 had become standard equipment in American and Allied infantry units. Nearly 50,000 had been produced. They served in every theatre where American forces fought. From the volcanic islands of the Pacific to the jungles of New Guinea, from the mountains of Italy to the hedgerows of Normandy, from the forests of the Ardennes to the final drive across Germany, the radio proved itself in the Battle of the Bulge during December 1944, when German forces launched their surprise offensive through the Ardennes. In the initial chaos, when American units were surrounded, cut off, scattered across frozen forests, the SCR-300 allowed isolated forces to maintain contact, coordinate defensive positions, and call for support. The radio's reliability in cold weather and its ability to function despite electromagnetic interference from vehicle engines and weapons fire helped American forces maintain cohesion during the critical first days of the battle. Some military historians have argued that the SCR-300 was among the most important pieces of communications equipment employed in the European theatre. That assessment may be debatable, but what is certain is that the radio gave American forces a significant tactical advantage that German forces never closed. The story of German engineers examining the captured SCR-300 is ultimately about industrial warfare and the revolution in manufacturing that occurred in America during World War II. It's about the transformation of warfare from an activity determined primarily by tactics, training, and courage to one determined by industrial capacity, technological sophistication, and manufacturing efficiency. The frequency modulation technology that so impressed German engineers examining the SCR-300 wasn't magic. It was established radio theory that German engineers understood perfectly well. What they couldn't match was the American ability to translate that theory into practical equipment that could be mass-produced by semi-skilled workers in quantities large enough to equip an entire army. This capability developed for radio equipment extended to every aspect of American military production. Tanks, aircraft, artillery, trucks, ammunition, all produced to standardized specifications in quantities that overwhelmed Axis forces, despite whatever tactical or technical advantages they might have possessed in individual engagements. Klaus Dieter, the signals officer who first examined the captured SCR-300 in Sicily, survived the war. In 1946, he returned to civilian life as an electrical engineer in Munich. He spent his post-war career helping rebuild German telecommunications infrastructure, applying lessons learned from examining American equipment about the importance of standardization, interchangeability, and design for manufacturability. In a 1972 interview for a German technical magazine, Dieter reflected on that August day in 1943 when he first opened the case of the captured American infantry radio. He said that he knew immediately, looking at the design and construction, that Germany would lose the war, not because of any single battle or campaign, but because the radio revealed an industrial capacity that Germany simply could not match. The Americans had industrialized everything from radio crystals to entire armies, applying the same mass production philosophy that built automobiles and refrigerators to military equipment. Germany, Dieter said, tried to fight an industrial war with craftsman methods. It wasn't that German technology was inferior. In many areas, German theoretical knowledge exceeded American, but theory doesn't win wars. Production capacity wins wars. The side that can build more equipment faster with less skilled labor will eventually overwhelm any opponent, no matter how brave or well-trained. Heinrich Weber, who directed the detailed technical evaluation in Berlin, did not survive the war. He remained in Berlin through the final Soviet assault in April 1945, conducting technical assessments and destroying classified documents until ordered to evacuate. His final report, dated April 23, 1945, assessed the latest American radar equipment and concluded that American electronics production had advanced so far beyond German capabilities that any hope of closing the gap was futile. Weber died on April 28 during the evacuation, killed when Soviet artillery struck the convoy carrying technical personnel westward. His papers, recovered after the war by American technical intelligence teams, included personal notes expressing frustration that his reports documenting American industrial superiority had been filed away rather than prompting meaningful changes in German production strategy. He wrote that German leadership seemed unable to accept that technical excellence without production capacity was meaningless in modern industrial warfare. The SCR-300 itself continued in service after World War II. It saw action in the Korean War, where its reliability in cold weather and mountainous terrain again proved valuable. Eventually, lighter transistorized radios like the PRC-10 and later the PRC-25 replaced it, but these newer radios built directly on the FM principles that the SCR-300 had proven in combat. The fundamental design philosophy embodied in the SCR-300, design for mass production, build in quality, standardize for interchangeability, became the foundation of modern military equipment development. The principles visible in the American radio in 1943 now govern military procurement worldwide. Every modern infantry radio, from the sophisticated software-defined radios used by American forces today to the simpler equipment used by militaries with fewer resources, reflects the lessons learned from the SCR-300. The story that began with a German signals officer examining captured equipment in Sicily in August 1943 concluded with the complete transformation of how nations prepare for and conduct warfare. The radio that Klaus Dieter held in his hands that day, studying its circuits and construction with growing unease, represented the future of military technology. Mass-produced precision equipment, designed for ease of manufacture and operation, produced in quantities that made individual technical superiority irrelevant. German engineers, who examined American radio equipment during the war, understood this transformation as it happened. Their reports documented not just technical specifications, but the end of one kind of warfare and the beginning of another. They witnessed, analyzed, and reported the future of conflict, that their warnings went unheeded in Berlin, that German leadership proved unable or unwilling to adapt to industrial reality, did not diminish the accuracy of their assessments. Today, the principles they identified remain fundamental to military equipment development. Mass production of precision components, industrial automation, standardization for interchangeability, design for manufacturability, these concepts govern every high-technology military system. The direct line runs from frequency modulation radios produced in American factories in 1943 to the sophisticated communications equipment used by military forces worldwide in the 21st century. The industrial philosophy remains the same, only the scale and sophistication have changed. The SCR-300 backpack radio weighed 35 pounds, used 18 vacuum tubes, operated on batteries that lasted perhaps 40 hours, and provided reliable voice communications over 3 to 5 miles. By modern standards, it was primitive. Today's infantry radios weigh a fraction as much, use digital encryption, operate on multiple frequency bands simultaneously, integrate with satellite communications and data networks, and provide capabilities that would have seemed impossible in 1943. But the fundamental principle remains unchanged. The side with greater industrial capacity to produce advanced equipment in overwhelming quantities will ultimately prevail. The Americans proved that principle between 1941 and 1945, producing nearly 50,000 SCR-300 radios, along with millions of other pieces of military equipment. The world has been adapting to its implications ever since. In an age of software-defined radios, satellite communications, and computer-controlled warfare, the fundamental truth that German engineers discovered examining captured American equipment in Sicily remains relevant. Industrial capacity, properly organized and directed, determines the outcome of modern conflicts. Without the ability to produce high-technology equipment in sufficient quantities, no amount of tactical skill, technical innovation, or individual courage can achieve victory. The German engineers who examined the SCR-300 in 1943 were not just studying a communications device. They were witnessing the future of warfare, the moment when victory stopped being determined primarily by battlefield prowess and started being determined by factory output. Their detailed reports, classified and filed away during the war, eventually became historical documents that explained not just why Germany lost, but how industrial capacity determines the outcome of modern conflicts. The conclusion, written in technical language but unmistakable in meaning, was that Germany had challenged the world's greatest industrial power with inadequate manufacturing capacity. The American infantry radio, with its FM modulation, automatic frequency control, precision components, and mass production design, told the entire story in a 35-pound package that any infantryman could carry. Industrial warfare demands industrial capacity. Without it, no amount of technical brilliance can achieve victory. That lesson, learned by German engineers examining American radio equipment in underground laboratories and requisitioned villas across occupied Europe, remains as relevant in the 21st century as it was in 1943. The names have changed, the technologies have advanced beyond recognition, but the fundamental principle endures. In modern warfare, industrial capacity to produce advanced technology in quantity determines outcomes more surely than any other factor. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.